Okay, I can't even remember what installment number this is. I think it's number 4, chapter 6, and I don't think it makes any difference. At any rate, we're going to continue on. We were talking about annuities, which are constant payments over time, and since there's a time value to money, an interest rate factor has to be applied to calculating what annuities mean and what their value is, and what we're talking about in terms of how much money do we need, solving for one of the unknowns of either a future value of an annuity or a present value of an annuity. All right, so let's see what we got here. We got an illustration of how we use the formula for solving for one of the unknowns of an annuity and seeing what it all means. We want to do the following. We plan to deposit $1,500 at the end of each 6-month period. So this spells, since it's at the end of each 6-month period, it spells the fact that this will be a ordinary annuity, because an ordinary annuity is done at the end of the period. So we at least know that we have an ordinary annuity. It's going to be for 2 years, and since it'll be over 2 years, it'll actually be 4 payments, one each 6 month of 2 years, 4 payments. 8% is our interest rate, so we can start now seeing what the formulas look like. 8% is the interest. 4 payments is the N. 1,500 is equal to the payment amount. And now we want to solve for the how much we'll have at the end of the 2 years, the future value. So the unknown is the future value of doing all this, paying $1,500 every 6 months at the end, an ordinary annuity. 4 payments, 8%. What's the future value here? Naturally, we go to a table, and it'll be called the future value of an annuity table. And naturally, we're going to use the concept of the periods here, which in this case will be 4. And we're going to use an interest rate. We were told it's 8%, but remember here that we are talking about 4 payments over 2 years. The interest rate is on an annual basis. That's per year. So now we have to learn how to adjust the tables when we're doing something less than annually, or you might say more than annually. We're doing it more than annually. Here we're doing it every 6 months, so that's twice a year. And that means that for each period, for each N, for each period, the amount of interest is half the annual amount, or 4%. 4% because it's for half the year. The whole year, 2 periods, 2 N's would be 8%, but half is 4%. So we have 4 periods, or 4 payments. This is the N. And here's the interest rate, the I, for every 6 months. And where the twain meets between the two is the future value factor to solve our problem. In this case, we're solving for future value. So using the preceding, let's see how it works out. We have 4 periods, and here's the factor. Let's prove it by going back. It's the same number, 4.24646, and that's indeed the right number, the right factor to use. Again, notice it's 4% because it's over 2 years at 8%. The 8% is for the year. So for every 6 months, it's 4% every 6 months. Suppose, just so you can see how it works, suppose we paid every quarter. Then we would divide the 8% by 4 quarters per year, and each period, each N would be 2% for each N, for each period. All right, you take the factor, multiply it simply times the amount of annuity payments being made, 1,500, and you will get, at the end of the period, your money will grow to $6,369. This is the future value. The present not the present value, but the total amount of principal being paid in, the P, so to speak, is $6,000. That's the simple principal being paid in, because it's simply 4 times 1,500. Excuse me. This is live and in person. Okay, pardon me. So you see that you pay in $6,000 of real dollars. The future value is greater, and the difference is the interest earned, or the interest factor, or the time value of money. This represents the time value of money during this period of time, this 2 years, the time value. In this case, we are looking at the future value, so we're seeing what 1,500 4 times will give us at the end of 2 years if it's 8% on an annual basis. And that's pretty cool, because it shows us that if we set up a savings plan, $1,500 at the end, which is an ordinary annuity, at the end of every 6 months, if we can get 8% per year, 2 years we'll have this amount, and then we can continue to grow it over time. So now we want to do the future value again, staying with the same future value table, but this time an annuity due, which means at the beginning of the period. We use the same tables, but we make an adjustment, just like we did for the present values and the future values. Or did we do that yet? Maybe we didn't do it. So, okay. Here we're going to talk about what we do when we need to make an adjustment for the annuity due. That's right, we haven't talked about how to do this. This is going to be brand new. First time you're going to do this. You're going to see what happens. Since this is the beginning of the period, we're going to make an adjustment to the future value table. Okay, so here you are. You still use the future value of an ordinary annuity. That's the table you use, the same table we were before. But now we're going to increase the factor that we find. We're going to increase the factor that we find by a particular formula. And the formula will be simply 1 plus the interest rate, so it's 1 plus I, equal to our factor for a annuity due. Seeing is believing, and let's see how it works, and then we'll discuss why. If the ordinary is at the end of, let's say, a year, and the due, the annuity due, is at the beginning of the year, it means we have one whole period, one whole N, that's earning more interest or costing us more money because the payment's either at the beginning or the end. It's costing us a whole more period because the payment for an annuity due is at the beginning. In other words, suppose you're the landlord, you're going to collect rent. You're going to collect rent at the end of the year. So at the beginning of the year, you don't have the money. You have it at the end. Well, the time value of that money doesn't mean anything to you because you don't have it in hand. But if you get it at the beginning of the year, now you have it, and the time value of that money to you is worthwhile. So what we do to get an annuity due down here is we simply add one period, or a 1, to our factor on the table plus the interest rate. And in this case, the one we were using a 4% interest rate because it was semi-annual. So we're going to take that plus the number 1, we get 1.04, and that's the factor that we had add to the table factor. So if the table factor was, and then we're going to get a little complicated here, I guess we're going to start really messing this slide up. Our real factor was 4. There you go. That was the factor per the table. We multiply it times the adjustment. So this is the adjustment for annuity due. We'll just say adjustment. So we multiply it by 1.04 and we get a new number, 4.41631, and that is the factor that we multiply the 1,500 by to get the answer for an annuity due. And look, for an annuity due, because we're paying it early, there's more interest. There is more interest. In fact, the more interest is $254.78 more interest, because the time value of money is at work earlier It's at the beginning of the period, or in this case, the beginning of a 6-month period. More interest, more time. That's what they equal, more time. And I'm running out of space. I got an idea. Now I can create, there we go, create more space that way. So we'll make sure everybody can see it. More time, more interest. And that's exactly what happened here. Okay, good problem. Illustrates how we take the future value of an ordinary annuity table, adjust it for annuities due that are at the beginning, and it also continues to illustrate the time value of money. All right, we're going to stop here, and we shall pick up and do the next slide, which will be the present value of an annuity when we return.